everyone, and welcome back to the DSS Break. It's great to have you with us today. I'm Anna Annison, the founder of Data Science Salon, and I'm streaming directly from our headquarters, which is beautifully located in the heart of Miami, just a few blocks away from the iconic Design District. And we're here live every week to discuss the world of data science, AI, and machine learning. And we chat about unique experiences and best practices with leading data professionals in a 15-minute break. And today I'm really excited to welcome Sanghamitra Deb, head of multimodal and generative AI at Chegg, and she's going to share insights on scaling LLMs personalized in the field of education. And I was actually just saying that education is more important to me now than ever because now I have kids. And with over a decade of experience, Sangha has spearheaded innovative initiatives in multimodal and generative AI focused on academic content creation and personalized learning experiences. And she has led teams scaling LLM-powered conversational AI platforms and developed cutting-edge solutions for education, such as anomaly detection, topic modeling, and natural language processing. And in addition, Sangha has a wealth of experience in time series modeling, computer vision, and recommendation systems. So I'm really excited to dive in with your experience and discuss how AI can really revolutionize learning and content creation, especially in the education field of education. Thank you so much for joining us for this DSS break, Sangha.
Thanks for having me. Excited to speak about all things AI and education.
Awesome. Well, before we dive into all that, can you tell us a little bit about the journey that got you interested in data science in the first place?
Yeah, that's a very interesting story because I have been mainly trained in astrophysics. So I did research for a long time and also got my PhD. And most of my educational background is in physics. But when you're doing like research and when you're doing astrophysics, a lot of your work is actually working with huge amounts of data. In case of astrophysics, it's from like telescopes like Hubble or JWST, and you're trying to understand how the universe works by finding patterns in that huge amount of data and fitting parameters, which is kind of very close to what people do with data science. So I would say around the time when I was doing postdoc, I was also interested on the human side of it and the human side of applications. Like most of the time, I was looking at the sky, but for a change, I wanted to look at the Earth. So that's when my mindset shifted towards moving to industry. And in my first job before Chegg, I was in Accenture Tech Labs, which was like a perfect place for me to transition between academia and industry. And then I was always interested in the space of healthcare and education. And so when I found the opportunity at Chegg, it was just perfect for me. Added to that, I feel very excited because this year the Nobel Prize in Physics actually went to machine learning. So John Hopfield and Jeff Hinton actually got the Nobel Prize, and I'm like, I am in both worlds. This makes me feel really good. But yeah, so I would say like the space of machine learning and data science has like very diverse people from very diverse backgrounds.
Yeah, and I think that's what really makes it so unique, right, as a field, because you can use your background to really come up with really interesting solutions, right, to these problems. So let's dive right in. And I know that leading the development of LLM-powered conversational AI at Chegg must be such a huge task. What are some of the biggest challenges that you faced while scaling these applications? Because that's really kind of, I feel like a lot of the conversation is about scale, right? How have you overcome them? If you have, maybe you're still working on some of these problems.
Well, we have developed a conversational AI system, and it is serving students. So we had to overcome a lot of the scaling issues. So you have to realize that when you're building the system, it's very different from anything that you have built before, because right now you have these large language models, which could take from several seconds to several tens of seconds to like create a content that's of high enough quality. And while this is going on, you need other parts of your engineering system to work to actually, make sure that, it's the data is ready to flow to different parts, and all the customers are getting served concurrently. So for all of this, you have to build like a completely new infrastructure. You have to make sure you have the right instruments for streaming. You have to think about like things like token limit. For instance, if you're using external APIs, even if it's your internal fine-tuned models, um, if you just blast it with like constantly ask questions, send like huge amount of context to these large language models, you're going to basically, like throttle the system. And so it's you have to remember that, even though large context size might give you very high quality answers, does it help with your scale? And then you make this like you make this optimization as, I will use this much context to write the prompts or to give the right instructions to the LLM, so that I can get so many outputs per second, so that my latency at the 99th percentile is, lower than a certain level. So these are things you're constantly thinking about. Another thing that people really do with large language models is ask for different types of outputs to render to students. And the idea is that the users and the students get like a very user friendly interface. So you might be asking for JSONs, you might be asking for SVGs, YAMLs, and all of these things. When you do this, you need to remember that, large language models hallucinate. So maybe 2 to 3% of the time they will hallucinate. So you need to have things like JSON validators. You need to have like other fail safes in place, so that when you don't get what you want, you can correct for it or detect it and not show it to the user, so that they don't have like very bad user experience. So there are like these are small things that you have to like worry about your entire system. And these are new things. Like we weren't worrying about these things before the large language models or the generative AI models were in place.
Yeah, no, I think it sounds like there's been a lot of new things that came on online once all of that had to be created. And I know that you've worked on creating personalized and academic agents, and that's a big thing right now. I was actually just judging a hackathon in Palo Alto all about agents and apps using agents and RAG, and basically getting rid of hallucinations and such. How do these AI powered agents enhance the learning process? And what role do you think they play in improving academic content delivery?
So when you think of an agent, what it means is that it's a system that has access to all of the data, and it's typically called memory, but this is like all of the data specific to your company.
Yep.
It has access to all of the tools specific to your company. In some companies, these tools might be like the weather API. And it has the ability to take all of this information, use the large language model or the generative AI model as like a brain where it can bounce off ideas, and then think about the system, and then come up with a plan of execution. So this is a system with a lot of capabilities. And the place where it can really help with education is that something like this can be present throughout the student's learning journey. So it can be there for the student when the student opens the book, or even before that, when the student is choosing the course, for instance. What courses should I take this semester? The AI agent probably has an idea of how you did previous semesters, what were your strengths, what were your weaknesses, and they can make suggestions to, these are the courses you should take. It might also know where you want to go, like what are your aspirations, what jobs do you want. So it can even suggest courses. And then once you're in the course, once you either open a book or your own online course, it can just be there with you, thinking what is the right next step for you. And it could be, that some students prefer short burst learning, and then the AI agent goes and finds out from the data that, this short burst learning process works well for the student. For other students, maybe you need like a really nice study guide that not only lays out, what you're doing this week, it gives you a plan for the whole semester, with the idea that, we will make changes based on your progress, and that gives them the vision, long-term vision of what they're doing. So it could be personalized, and it could also be something that's there throughout your journey. It could be something that tells you, tomorrow is your exam, you're too stressed, you should probably stop studying. you've learned enough, like go to bed. So it's like it can be this like holistic system that's there with you and adding value in every step of your education.
So why do we need a teacher then after that? Set,
Well, this is a very good
like,
question, but we still do. So I think AI agents can also be form a really good set of tools for teachers. So as a teacher, like you would have like an entire class, and sometimes teachers have to teach large classes, right? And giving individual attention is always not possible, maybe because of the size of the class, because of the number of classes they teach. So the AI agent here could also go and collect data on each of the students and sort of make suggestions. And and the teacher is really important here, because at the end of the day, um, using that suggestion and creating something more than that suggestion is the job of going to a class and teaching. But your teaching can become very focused, very personalized. Maybe like you create personalized homeworks for everybody, or personalized learning materials for everybody. So I think in every step, having a human in the loop is very important, because we also know that there's hallucinations in these systems. We also know that there are system failures. So like constant monitoring, constant human intervention should be there. And for something like teaching, which is, I feel, very personal, very how should I put it, students are also very impressionable, so you really don't want to give the wrong information or the wrong thing. So AI agents could be great teacher assistants as well.
yeah, no, it sounds like they would make teachers' lives much easier, actually. And
Yeah,
so,
precisely.
awesome. And you mentioned using small language models to mimic LLM performance. Can you explain how this works and why smaller models are sometimes more efficient and effective?
Yeah. So now that we have large language models, pretty much any team, like you don't need machine learning engineers, any team with some engineering knowledge product, you could write some prompts and get the machine learning results. So it could be classification, it could be getting bounding boxes out of images, it could be all of these things, right? But at that point you should ask, should I really use a large language model to do this? Because this is a model that has high latency, you're token limited a lot of the times, and what you're going for is maybe a pretty simple classification task, a pretty simple bounding box detection task. So in these cases you could use the large language models, combine it with human feedback in a more of an active learning way, so that you create some data, get some feedback, change your prompts, give the feedback in place of feedback into the prompts. So use a large language model along with humans, create training data, and then create a small model which could have like 100 to 200 millisecond latency, which an intelligent agent can call at any time during its process, and they don't have to be limited by any of the latency issues or any of the other issues of a very, very large model.
Got it. No, that's a great answer for that. And the next question I have for you, and I'm sure you get this all the time, how do you ensure that these models, especially those used in educational content, remain unbiased and ethical in their outputs? And you mentioned hallucinations as well. I know that having human in the loop is definitely helpful, but what are some of the other things we could do? Because it's very sensitive with education, like misinformation, as you said, is super, it's a very dangerous thing.
Yeah, and that is a very good question. And I think that is something we have to keep in mind all the time. So things that we are we do right now is that, we have different types of moderation for any content that are generated. Some types of moderation are pretty generic to large language models. So you have moderation so that PII is not exposed. You have moderation for profanity. You have moderation for some general things, and then there is moderation for education specific things as well. um, that is like one part of the story. The other part of the story is like a constant monitoring and evaluation. So you should always make sure that, let's say you're developing a new part of a product and you're infusing it with some kind of AI answer or AI summary, AI something. So you're calling a large language model and getting some kind of content. For that piece of content, there should be like full transparency, full observability. So part of it is doing like humans, using humans to see a percentage of your content that's created and give feedback. But part of it is also to do like automated evaluation. So you could
Right.
use 3 or 4 large language models as judges. You could give different types of prompt instructions to it. And these things are becoming like cheaper and cheaper to use. And you could have your entire data run through that and trace every part of your data. And so that would give you guardrails as to how your data is performing, what types of content is generated. So I would say like full on observability, transparency. Another direction is, what do you mean by ethical and unbiased content? And that can be different for different domains.
Yeah.
And in education, it's important to have like inclusive workshops where you have people from learning, people, educators, like other people involved in developing syllabuses, like a large group of people, getting them together and sort of defining what is an unbiased, what is an unbiased content, what is like, what content is ethical. And this is not like set in stone. This will evolve. Like if you say, like some of the things we do is, when you have data, you make sure that the data is diverse, and there are different methods to do it. But then you have to define diversity, and it evolves. Like 10 years later, there might be 3 or 4 other groups in diversity that you'd have to measure. So keeping that open mind, that just because I have done everything, I have defined it, I can't just sit back and relax. I have to be aware that if new forms of biasness or unethicalness is creeping in, and make sure that the system that we have can handle it, handle a new definition, handle observing it.
Got it. No, that's a great answer. Thank you so much. And my last question for you would be is, what do we kind of see as the future for this? I know that we talked a lot about, agents, but where do you see things going in the next couple of years with content creation and just education and AI in general?
So I will divide this question into 2 parts. One, I will just talk about education, and then in the other part, I would talk about like machine learning and AI and where I think it's going. So in education, I would say the possibilities are endless. So let's say you're a student and you have finals coming up, and one of the finals is chemistry labs, and you are struggling with this titration experiment where you take the pipette and the burette, you add different chemicals, and you're supposed to measure a certain thing, and then the labs only have so few office hours. It's just not enough time for you to practice and get the right numbers. Now imagine you have a virtual reality lab where you can go and practice this 1,000 times and get to perfection. So that's like kind of where I see with education. You will have enormous tools at your hand, and then these tools eventually will not eventually like these tools can be personalized pretty easily at that point. And then you have these different forms of reality where you can go and do different tasks. And this is not to say that the labs are not necessary. I think you still need the labs to actually perform the experiment and see how it goes ahead. But this could be such an augmentation to like all of the work that students are doing. So I would say this is an example, and in a more generalized sense, like things will be more personalized. There would be personalized tutoring, and we won't get to the virtual reality lab on day one. It will all be like small iterative steps until we go to that virtual reality lab. In in this field of machine learning and AI, where especially with these generative AI models and large language models, um, I do think that at some point um, the models will have trained on all of the data that's available, and the performance will reach a plateau. But that does not mean that the field will stagger. What we'll have new innovative applications like oil and gas industry. I mean, it's just an example, but so the space of applications will still keep innovating. There will also be, of course, a lot of hardware innovations, I think, which will make things cheaper, faster. And then there will also be these set of models which are very domain specific. With domain specific data, they will not be as large. They will be smaller models, which will be much easier to use. And there will be a lot of work in that space, so that you have like every domain, every company has their own suite of smaller models doing similar things. And those things will get much easier than it is right now.
Yeah, no, I think that's a great answer. It sounds like efficiency is where we're going with all of this. So thank you so much for spending time with us today. Sangha, was for sharing your expertise. It was super interesting. And I'm really excited to meet you in San Francisco. And
Me too. Me too.
guys,
Looking forward to it.
yeah, if you guys enjoyed this session, Sangha is going to be speaking on the panel, and I'm sure there's going to be a lot of these kind of things that we talked about being touched on the panel on November 7th at Google HQ. And we're really excited to seeing some of you guys there. And yeah, as I mentioned, we've been working together, Sangha, I feel like for a little while now, but I've never met you in person. So it's really nice. It's going to be really nice to connect.
Yes, definitely. Looking forward to meeting you and the conference itself.
Awesome. Well, thanks everybody for joining us. Have a wonderful rest of the day and weekend. Bye.